Hi guys, so today we are going to continue our characteristics of graphs. Again, this is just kind of some basic vocab type stuff. You're going to see this throughout the year. It's going to come up multiple times with each of the different functions that we do. So last class we looked at domain and range. We talked about interval notation. We're going to use interval notation a lot today. But really, we're going to focus on some of the other characteristics besides domain and range. So the first one that's probably new is something called end behavior. And really, end behavior is exactly what it sounds like. What are the ends of my graph doing? So really, we're looking at the arrows that fall on the ends of our graphs. So if you look at this first one, we've got one arrow over here, and I've got one arrow over here. So what I'm going to do is I'm going to write a statement for each of those to say what your graph is doing. So the way we write this statement, we're going to say, as x approaches negative infinity, f of x approaches something, and we're going to fill in the blank. So that's the first statement that we're going to write. So what this means, as x approaches negative infinity, that means my x's get smaller and smaller and smaller. So as this graph moves more and more and more to the left, so the further left it goes, we're going to say what the y's are doing. Well, in this case, my y's are getting bigger as this graph goes farther and farther to the left, which means that f of x is approaching positive infinity. Now we're going to write a similar statement for the right side. So as x approaches positive infinity, we're going to say what f of x approaches. So as my x's get bigger and bigger and bigger and bigger, my y's are also going up. So my y's are approaching positive infinity. So I have both of these statements because there's two sides to this graph. All right, let's look at the next one. So we're going to start with as x approaches negative infinity. What is y doing? So as my x's get smaller and smaller and smaller, those y's are getting larger and larger. So f of x approaches positive infinity. Looking at the right side, as x approaches positive infinity, my y's are getting smaller. They're getting smaller and smaller, so they're approaching negative infinity. All right, if you feel comfortable, pause the video, try this next one on your own. All right, as x approaches negative infinity, f of x is getting smaller, so it's approaching negative infinity. Right side of my graph, as your x's approach positive, so as I go more and more to the right, your y's are getting smaller, going towards negative infinity. Now, everyone we looked at so far has been either positive or negative infinity, but that's not always the case. So let's look at an example of a graph that you saw back in Algebra 1. So back in Algebra 1, you guys looked at exponential functions, and you talked about that horizontal asymptote. What that meant is your graph got closer and closer and closer to that point, but it didn't actually touch it. So let's look at the left side of this graph. As x approaches negative infinity, so as your x's are getting smaller, your y's aren't really getting bigger or smaller. Your y's are getting closer to that horizontal asymptote, which has a y value of 0. So not every one of these will be positive or negative infinity. All right, as x approaches positive infinity, our y's are approaching positive infinity. All right, the next one we're going to look at is pretty easy. Again, this is one you've done before. We're talking about minimums and maximums. Now, you're going to see an extra word on here, though. We're going to talk about the global max or min, or the absolute max or min of this graph. The reason we're using kind of that extra word than what you maybe have seen previously is because later on this year, we're going to talk about a different type of max or min called a relative or local max or min. Now, we're going to wait, like I said, until probably next semester to really get into this when you see these more often. But that's a special type of minimum that's not the very highest or lowest point on the graph. So for this one, again, we're talking about either global or absolute. You can use those words interchangeably. So looking at that first graph, that graph does have a lowest point on it. So this point right here, that is the absolute or global minimum on that graph. This graph does not have an absolute or global maximum. It only has a minimum because this graph continues to infinity in both directions. Now, when we talk about that minimum, pay attention to what your question's asking for. If I want to know where that is, I would use the x-coordinate. But the actual value of the minimum is the y-coordinate. So it actually has a minimum value of -3. That's what the actual value of the minimum is. It happens when x equals -1. All right, looking at this next graph. This next graph does not have a minimum or a maximum, a global minimum or maximum, because this graph continues to both positive and negative infinity. And then this last one, so this graph doesn't have any arrows. It has a clear start and stop point on it. So we can find the absolute maximum, and we can also find the absolute minimum. All right, so now, like I said, we're going to get back into interval notation. So whenever we talk about an interval on a graph, we're going to use interval notation, but we're specifically talking about the x values. So if I say from the interval of 1 to 7, it means from the x value of 1 to the x value of 7. So that's what we're going to use for our interval notation here. So we're going to talk about two different types of intervals: increasing, decreasing intervals, and positive, negative intervals. Now, the reason a lot of people struggle with this is because we're going to write the x values where these things are happening. But to figure out what's happening, we're looking at the y's. But again, when we list an interval, we're listing x values. So let's start with increasing and decreasing. So increasing and decreasing, kind of think about it like positive and negative slope. As you look left to right on your graph, if the y values are going up, your graph is increasing. So this section of that first graph, even though that arrow right there is pointing down, it doesn't matter because we're reading this graph left to right. So left to right, as my x's get bigger, my y's are getting bigger. So that section of my graph is increasing. Same thing on this section right here. As I look left to right, as my x's get bigger, my y's get bigger. So those two blue sections is where my graph is increasing. Now to list where that's happening, I'm going to list the x values. Because again, we're saying where on what interval. So the x values there, well, that arrow keeps going to the left. So that's from negative infinity all the way until the x value of 1. Then it continues, it picks back up at 3, and then it continues until 5. Again, we're listing x values here. Now, I will tell you with parentheses and brackets on increasing and decreasing. The definition that we're going off of in this class, we're going to use parentheses. Now, in future classes, you may use some brackets to describe these increasing and decreasing intervals, and that's okay. There's a little bit of that depends on what kind of definition you're working from. In this class, though, we're going to use parentheses on these intervals. All right, so now let's look at decreasing. So the interval in this graph that's decreasing, I'm going to highlight that in orange, because as I look left to right, as my x's get bigger, my y's are getting smaller. So that's the interval where it's decreasing. So I'm going to list those x values. That's going to be from 1 to 3. All right, the next part is positive and negative. So positive intervals, again, we're talking about the y's. It means when is the y coordinate positive? Basically, when is this graph above the y-axis? So I'm going to highlight that part in purple. And to describe where, I'm going to use the x values and write that interval. Well, that purple part starts at 0, continues to 2. I'm using parentheses on these because at 0, it doesn't actually have a positive y value. When x is 0, y is 0. And 0 is not a positive number. 0 is 0. So I can't use a bracket on that. Then I'll go to the next interval. It goes from 4 to 5. I'm going to use a parenthesis on 4 because, again, when x is 4, the y value is 0. But at 5, the y value is not 0. The y value actually has a positive number. So when x is 5, it does have a positive y value. So we're going to use a bracket. All right, then let's talk negative. So negative is the stuff that's below. Again, we're listing x values. So negative infinity to 0 with a parenthesis and 2 to 4. All right, let's look at this next one. Okay, increasing. So I'm going to go ahead and highlight that section. So this part right here in red. So from negative 6 to negative 2, this graph is increasing. Decreasing right here. So from negative 2 to 2, this graph is decreasing. So you're probably wondering, well, what about this little part down here? Well, that's not really increasing or decreasing. So what we call that is constant. So this graph is constant from 2 to infinity. All right, let's look at positive intervals. So this graph is positive right here. And your graph is negative right here. So what I'm going to do on this one, though, is I'm going to review a little bit of Algebra 1 for you guys. We don't know that point exactly. So we're going to solve for that point exactly algebraically. So what I'm going to do is I'm going to find, well, what's the equation of this line? Well, that line has a slope of 2. And if that slope of 2 continued, it would have a y-intercept of 7. I want to know what this point is right here when y is 0. So 0 equals 2x plus 7. So I get that the x-coordinate is negative 7 over 2, or negative 3.5. So now I know what that point is exactly. Well, let's do the same thing for the other point. So let's find the equation of this line. So this line has a slope of negative 5 over 2 and a y-intercept of negative 2. I want to know what this point is. That point has a y-coordinate of 0. So I get that x equals negative 4/5. So now we can find this interval. Let me go ahead and re-highlight it. Here's our positive interval. I know those points exactly now. It's from negative 7 over 2 to negative 4/5. All right, the negative interval, that's going to be this part here in pink. So it starts at negative 5. Negative 5 actually has a point there. That point actually has a negative y value. So we're going to use a bracket. Then it's going to continue until negative 7 over 2. Then it's going to pick back up at negative 4/5. And then it just continues until infinity. All right, then our last ones. A lot of this is actually review from Algebra 1. The last one, the notation may be a little bit different. So we're going to evaluate f of 2. So what that means, remember, that means when x equals 2, what does y equal? Well, when x equals 2 on my graph, there's 2 points there. One of them is filled in, and one of them is not. The filled in point is the actual value. Remember that open circle means I get as close to that point as I possibly can, but I don't actually touch it. So f of 2 is equal to 3, because that's the y-coordinate of that point. All right, find all values where f of x equals 1. So when y equals 1, there are 2 points. Negative 1 and 1. And then the last one's actually a really easy Algebra 1 question, but the wording on it gets confusing for some people. Because again, we're talking about interval notation. Find the average rate of change on the interval negative 2 to 0. That means from the x value of negative 2 until the x value of 0. So those are 2 x values. So when x is negative 2, there's my point on the graph. When x is 0, there's my point on the graph. It wants to know the average rate of change from one point to the other. So all it's really asking for is what's the slope of that line? Well, that's pretty easy to find. Count your rise or run, and that slope is negative 2. It's just a matter of being able to read the question and understand what it's asking for. So again, that question is asking for the average rate of change, the slope, from the x value of negative 2 until the x value of 0. All right, so that's it for your vocab for today. Again, these are things that are just going to kind of keep coming back up throughout the year. The more comfortable you get with them, the easier it's going to make things for you.